Hello YouTube viewers, this is Edgar and I'm welcoming you to the VinyLiberator Blue Collar Economy Edition video. My first VinyLiberator Pre-Amp was a nice unit. It was a little more expensive to build and had more features than it actually needed. The original one, I used the OPA 1642 op amp for the stage 1, and I used an LM 9562 op amp for the stage 2. They give a few dB less noise than this particular circuit, but each one of those ICs was about $5, and then the LED level indicators was circuitry that we really don't have to have. And what I wanted to do was to build an inexpensive version that was real close in performance, and basically a version that just about anyone who's handy with op amps and electronics and building on perf board could build for low cost, but yet high performance. Now, I was really blessed. A couple months ago we upgraded our internet service, and by doing so we got to make this Westel DSL modem obsolete. And it's a cute little cabinet here of maybe 3.5 by 3.5 inches, which happened to be just the perfect size to build a preamp in. And these have light pipes to carry the light from the LEDs up, so I've put a power indicator LED on this board. Comes straight up out of the board, shines into the one on the left, so it even has a power indicator. Now, beauty of this circuit is that it uses a TLO72 for both the stage 1 and stage 2 amplifiers in this thing, and these are 50-cent chips, so they're really inexpensive, and yet we're only talking about a few dB more of noise, which is already probably better than 60 dB below signal level anyway. So it's a remarkably good sounding preamp, and pretty inexpensive to build. Now, because of the way I've arranged the feedback in these, and we'll show the schematic later and I'll go into the details, because of the way I arranged the feedback for the equalizer section and the times 100 voltage amp, and because I'm using Mylar capacitors to couple the output to the output jack, which is my typical 3.5 millimeter jack that I use, since I like to either feed it into a computer or a stereo rack where I'm using a lot of 3.5 millimeter 1/8 inch stereo connectors anyway. And it saves room on the panel, so that makes it cool too. And then it means there's only one set of RCA jacks, so you can't accidentally plug your turntable into the output. With two different types of connectors, you're always going to plug the turntable into the input. And that's pretty much it while we're here. And since the capacitor is big sticking up, this one runs on plus and minus 5 volt rails. It's not a lot of voltage, but it still clips at about 8 volts peak to peak, and that's way higher than any reasonable cartridge could ever be expected to go. And any of these that are built for a client can also be provided with gain controls, so even if clipping or overload were an issue, the gain could be adjusted anyway. This is basically a prototype, and I'll use it occasionally on the bench when I'm doing turntable repair, or I might use it out in the field somewhere if I'm using a turntable at a music show or at a radio station, or just about anywhere where I can hook up a preamp. This little baby will do it. So we'll go into pause, and then we'll come back with schematic, I guess. Okay, if you'll excuse me for a second, before we get to the schematic, I thought I would go ahead and show the back panel, the rear apron of this thing. I don't have the labels on it yet, but it was a bit tricky to get that perf board cut to where it would drop right in this little modem case, and didn't quite get the latches on it popped right back together exactly right, but it fits, and it took a little bit of diligent effort and a little bit of cutting and trimming and proper mounting of these jacks to get everything to line up and work, but it fits, and it's a real handy format to use it in. Of course, we got your excuse me, got the right and left magnetic inputs. I soldered a piece across a miniature alligator clip and then tied it to the circuit board, to the perf board, with several pieces or several runs of the steel paper clip wire, so it's securely mounted. And this bar is to lift up on it, you lift up on it and you can either stick a ground lug in it or just a bare piece of wire. So whatever your turntable is using for a ground, alligator clip seems to be the universal connector that works right. So that's what I'm going to do. Is use I've been using alligator clips for grounds on these things. They're reliable and it does a good job and they're cheap. Now the power input, this uses a positive and negative power supply, and it's fed by half wave rectified supplies. So we're feeding AC into this, and what I do, the adapter that came with this did have AC output, but it was kind of heavy and it was way too big to run a preamp, and it ran a little warm, so it was wasting power. So I took a smaller DC output AC adapter, and I took the rectifiers and filter capacitor out of it, and I was inspired. I came up with a new technique to open one of these. It bears repeating and bears showing, because usual technique is to hit it with a hammer until it breaks open, but I've got a miniature hand, well, I got one right here, I can pull it out. I have a mini hacksaw that just holds the blade, and with a mini hacksaw you can cut into a corner of an AC adapter just a little bit, and then that gives you a notch that you can stick a screwdriver into it and twist it, and you can actually crack the case open without having to bang on it. So if you happen to have a DC adapter and need AC to run one of these, I recommend getting a small 9 volt or 12 volt DC adapter, because they're more common, and saw the corner a little bit where you can get a screwdriver in it, stick a screwdriver in it, twist it, and it'll pop it right open. So that's how to get the AC adapter open, and of course to change its output from DC to AC, like I said, you just take the rectifiers and filter capacitor out, and then connect the output cable just directly to the transformer secondary, and that's how you do it. So now we'll go to the schematic, and I'll go over the circuit a little bit. The schematic on this, if I had it all on one page, would be too small and wouldn't show up on the camera very well. So I went ahead and broke it down into 3 major parts. The first section is one channel shown, because second channel, the right channel, is identical in circuitry. Of course, we only have one ground strap, and both channels share the common ground. Now we have, of course, RCA input jack using a 0.33 coupling capacitor. Now a magnetic cartridge doesn't have any DC on the output, and the input of the op-amp operates at 0 volts DC, but in case you hook it up to an audio generator or some other signal source that may have a little bit of DC riding on it, it doesn't hurt to have a coupling capacitor to isolate the DC. Cartridge, typically American cartridges, in fact worldwide cartridges, are loaded with 47 kilo ohms. I advise using a metal film resistor because they have lower noise level. If your cartridge requires more than, say, 300 picofarads of load capacitance, you may want to add an extra capacitor. Otherwise, I use Audio-Technica cartridges. Their optimum load capacitance is from 100 to 200 picofarads, and the tone arm wiring and interconnect cable wiring will provide that, so I run mine without any form of input loading capacitance. I'm not sure if the cartridge resistance will affect the frequency response or the action of the equalizer circuit, but just to put all cartridges on equal footing, since a cartridge is typically 700 ohms DC resistance, and since adding a 1K in series would have no effect on the audio gain, I went ahead and put a 1K metal film resistor in series. That puts all cartridges as a pretty much equal effect on the front end of this circuit. Now the first stage is an equalizer amplifier, and the way I do that is we use a 56K resistor from the output to the inverting input, and then a 5.6K to ground. That divides the output signal by a factor of 10, a voltage division of 10, so that gives the amplifier a gain of 10 without the capacitor. Now the capacitor at 0.1 microfarads has enough reactance or low enough impedance at 1K and 500 hertz to where it causes this to act as a direct connection. The impedance is low enough to where it forces the amplifier to go into unity gain. As the frequency goes down, the reactance or impedance of the capacitor goes up, and by the time you're down to 20 hertz or so, the capacitor has no effect. So basically it's causing the gain of the amplifier to slope upwards as the frequency goes down, and true to the RIAA equalization curve, this will cause the 20 dB required boost at 20 hertz. Now for the high frequencies starting at 1 kilohertz have to go on a sliding scale down, and they have to be attenuated 20 dB, or a voltage factor of 10. They have to be attenuated down to 1/10 of the 1 kilohertz voltage level. And the way I do that is it takes about 4.1 to 4.2 K in series with a 0.02 capacitor to cause that kind of a frequency slope. So the high frequency filter, or the high frequency curve in this, is produced passively. Now the beauty of my circuit is that by putting the high frequency reduction filter after the first stage, it reduces the noise level of the first stage correspondingly. First, the first stage has unity gain at the higher frequencies, so it doesn't contribute that much noise to start with. And then on top of that, what noise it does contribute is filtered by the RIAA high frequency roll-off. So that pushes the noise level way down. Now I've got a client who's interested and who potentially may want to have one of these. So he asked if I could do one with a mono switch, and mono switch is in the next stage, so I'll go do it later. In fact, the gain control that he asked for is also there. What we'll do though, the high frequency roll-off can be made variable. Instead of this 47K resistor, 100K pot could be put in, and that would allow it to be accurately and just totally set just right on the money. Now the scratch filter, since this is a high frequency reduction filter anyway, the scratch filter, one for each channel by the way, can be a capacitor that's switched in and added across this one for even a steeper roll-off. So in an event where you want to record an old scratchy record, and this capacitor, I'm going to choose it by ear for a moderate but very noticeable effect, because you want to filter the scratch and distortion out, but at the same time you want to leave as much of the music as you can. So I'll go ahead and put a scratch filter in there. Now the signal after this first stage has been completely de-emphasized, where it was RIAA emphasized coming out of the cartridge. By this point, it's frequency flat all the way across the audio band. But in order to avoid any interaction with this roll-off network, the 100 times voltage amplifier has to present a high impedance at this point so that it won't interfere with the roll-off characteristic. Okay, I got less than 2 minutes on part 1, so this will obviously be a multi-parter. This is one channel shown only. We're using a 0.2 coupling capacitor because in order for me to avoid using electrolytic capacitors in the feedback networks, I have to tolerate about 300 millivolts or so of offset appearing at the output of stage 1 and the output of stage 2. So using a 0.2 here, that means that this one is not influenced by the DC offset of the first stage, and have a 100K going to ground, and that provides the DC path for the bias network inside the op amp so that it'll always stay centered and biased. Like I was saying before, this whole system runs on plus and minus 5-volt rails, so I don't have to have a bias network for these, just a path for just a DC path. Now I'm using 100K and a 1K for the voltage divider in the feedback loop. That gives it a voltage gain of 100. My client's interested in gain control, so instead of this being a fixed resistor, it'll be a pot. Please pause. We're going to do a part 2 coming right up.